We're going to look at an application of a 3x3 system of equations, and this involves pumps. So 3 pumps, pumping capacity of the pumps. These are additive. These pumping capacities are additive because we assume if we have 2 pumps working that they will each pump their full capacity. So our first statement is that when all 3 are running together, their pumping capacity is 2,900 gallons per hour. This will get us an equation as soon as we have defined our variables. We're going to let A represent the pumping capacity of pump A. And similarly for B and C. We can use ditto marks to make this more efficient because it's still clear what each variable means. When A, B, and C are running together, we can add their pumping capacities and we get 2,900 gallons per hour. If only A and B are running, we get 2,200 gallons per hour capacity. So that tells me that if A and B, we would add the pumping capacities of A and B to get 2,200. And finally, only B and C, we get 2,100 gallons per hour. So the equations get more and more obvious as we continue. So B plus C is equal to 2,100. You can see that I'm setting up my equations in a way that's going to make it easier to draw the matrix. I can see where the zeros are going to have to go, right? It makes sense to line up your A, B, and C or X, Y, and Z variables when setting up your equations if you're going to be putting them into a matrix. So that my first row is 1, 1, 1, 2,900. Our second row is 1, 1, 0, 2,200. And our last row is 0, 1, 1, 2,100. Now, following that order rule, I can see that I already have a 1 in the upper left corner, and so my next step is to get zeros below it. This is the only one that isn't already 0 below it, so this is the one I'm going to target first. I can make that equal 0 just by doing the transformation -1 times row 2 plus row 1. Really, you can multiply either row by -1 and it'll work. I chose to do row 2 by -1 instead of row 1 just because I can see that this number is smaller, and that's going to avoid the unnecessary creation of negative numbers. This one is simple enough that we can probably just figure out what the result is without writing anything out, right? So our first row is staying the same. And for this row, I'm just going to subtract. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 0 is 1. And 2,900 minus 2,200 is 700. And the bottom row is staying the same at this point. So at this stage, this is a much simpler than average Gaussian elimination. At this stage, column 1 is already done, so that means we can't use row 1 in any more transformations. I'm looking at just this lower matrix and thinking about getting column 2 in place. I can see the easiest way to do that is going to be by swapping row 2 and row 3. So we'll redraw this matrix with row 3 and row 2 swapped. And what we see when doing that is that we got lucky and a lot of things just fell into place accidentally, right? We've already got this in row echelon form. So all we need to do now is read off the equations and back substitute. So A plus B plus C equals 2,900. That one really didn't change. B plus C equals 2,100. That one also didn't change. C equals 700. That's the new piece of information that we got out of the matrix. So plugging in 700 for C in the equation above gets me, let's give ourselves a little space here, B plus 700 equals 2100. And then subtracting 700 from both sides, we can see that B is equal to 1400. So now we're ready to plug in for C and also plug in for B in our original equation, our top equation. And this gives us, we'll go ahead and write this one over here where we've got space, A plus 1400 plus 700 equals 2900. Combining terms gets me A plus 2100 equals 2900. And subtracting 2100 from both sides gets me to A equals 800. So I should express my final answer. I have values for A, B, and C, but I should express my final answer with labels and units, since what we're talking about here is pumping capacity in units of gallons per hour. So let's go ahead and write up what that final answer should look like. So with labels and units, we have units for each of these pumping capacities, and we have labels by each one so that it's very clear which number goes with which pump.